Hello everyone. In continuation to kinematics of particle, we will now talk about impulse and momentum. So momentum is the mass times the velocity, and we have here the principle of momentum. Basically state the integral from t1 to t2 of f dt is mv2 minus mv1. And now impulse is basically the force times time, same thing, integral f dt. This is impulse. Now, so let's do maybe a quick example on that. We have a body, weight is 981. We have the reaction, we have 200 Newton acting on it, 45 degrees. We want to know, it's starting from rest, we want to know what's the velocity after 10 seconds. So we do conservation of momentum. mv1x plus the integral mvx2. So notice this is 0. Plugging in, we have, so this is going to give you f d2 minus d1. So plugging in, this is 10 seconds times 200 cosine 45. Notice we're doing in the x direction. For the conservation of momentum, you can break it down into x, y, and z. And now it's going to give us 100 v2. Now notice, the body is only moving in x, it's not moving in y. So we get 14.1 meters per second when we solve this. Now we want to know what is the reaction and C. Now of course we can just do sum of forces, but if we want to solve it using conservation of momentum, we can, doing the same thing, and C times 10 seconds, so that's F delta T, and we have the weight 981 times 10 plus 200 sine 45 times 10. This is gonna give us 0 because, well, we don't have an initial velocity or the final velocity in the y direction, and we get NC equals 840. So those are the two answers we were looking for. Now, if we keep going, we have, that's the conservation of momentum we already talked about. And so the sum of mi vi1 equals sum of mi vi2. Now let's talk about impact. Let's say two bodies moving in this direction, VA1, VB1, and then they become here. Now we have VA2, VB2. We now want to know the velocities. So we have something called coefficient of restitution, E, and E is basically this equation. Now usually in the problem you are given E and then you're asked to find one of the velocities, or you're given the velocities and you want to find E. So E is basically VB2 minus VA1 over VA1 minus VB1. Oh, 1 second, actually, let me double check that. I think this might be a typo. Oh, this is VA2. So it's VB2 minus VA2. Now moving on, we also have angular momentum, which is mv. This is the linear momentum times the moment r, the distance, basically the perpendicular distance, which is also r cross mv, and we can do that from the cross product. And we have the same equation as the conservation of linear momentum. We have conservation of angular momentum with this equation over here, HO1 plus some integral to 1 to 2 and O dt equals HO2. Now if we have a problem here, moving in a circle, 100, we have velocity equals 5, force equals 150 squared, mass is 1.5 megagrams, which is 1500 kilogram. Now doing the conservation of momentum here. Now notice this is angular momentum. Since it's rotating in a circle, we have RMVC plus integral T1 T2 RFDT equals RMCVC. So plug in numbers. Oh, so yeah, the force here, blah blah blah. We only unknown we have is VC. Oh, notice actually this is 0. Yeah, and this is for the weight times 5, and we get 9.17 meters per second. Now this concludes this chapter. Thank you everyone for listening.